Everyone, I am Assistant Professor Kutiyakshada from S&T Engineering and Research Center, Evla. Today's topic is quantum dots. What is quantum dots? Quantum dot is a nano-sized semiconductor crystal which leads may unique optical and transport properties. A typical quantum dot has a diameter in the range of 2 to 10 nanometer. Examples: CDAC, PBAC, PBTE and INP. Basic structure of quantum dots. In this diagram, quantum dot are present. In middle, quantum dot core, and the outer shell is called quantum dot shell. In middle, a variable organic metal semiconductor quantum dot core, and in outer shell variable quantum dot shell comprise of second semiconductor layer, and the outermost shell variable outer layer depending on needed solubility and or biological properties, that is peptides, antibodies, oligonucleotides, polyethylene glycol, etc. How to make quantum dots? Quantum dots can be made by various methods such as lithography, colloidal synthesis, epitaxy. First, colloidal synthesis. Immersion of semiconductor microcrystal in glass dielectric matrices, taking a silicate glass with 1% semiconducting phase. Heating for several hours at high temperature. Then formation of microcrystals of nearly equal size. Typically group 2 and group 6 materials. Size variations. Epitaxy, that is pattern growth. Semiconducting compounds with a smaller band gap are shown on the surface of compound with a larger band gap. Growth is restricted by coating it with a masking compound and etching that make mask with the shape of required crystal, cell wall shape. Disadvantage: density of quantum dots limited by mask pattern. Epitaxy, self-organized growth, uses a large difference in the lattice constant of the substrate and the crystallizing material when the crystallized layer is thicker than the critical thickness. There is a strong strain on the layer. The breakdown results in randomly distributed islets of regular shape and size. Disadvantages: size and shape fluctuations, ordering. Quantum dots materials, their size and emitted wavelengths. In this structure and in this diagram, there are wavelengths are represented. Applications of quantum dots. Computing. Quantum dot technology is one of the most promising candidates for use in solid state quantum computation. By applying small voltage to the leads, the flow of electrons through the quantum dot can be controlled, and thereby precise measurements of the spin and the other properties therein can be made. With several entangled quantum dots or qubits plus a way of performing operations, quantum calculations and the computers that would perform them might be possible. QLED. Quantum dots may someday light your homes, offices, streets, and entire cities. Quantum dot LEDs can now produce any color of light, including white. Quantum dot LEDs are extremely energy efficient. They use only a few watts, while a regular incandescent lamp uses 30 or more watts for the same amount of light. Photovoltaic devices. Quantum dots may be able to increase the efficiency and reduce the cost of today's typical silicon photovoltaic cells. Quantum dot photovoltaic would theoretically be cheaper to manufacture, as they can be made using simple chemical reactions. In quantum dots are used in solar cells. Photovoltaic effect. p-n junction, sunlight excites electron and creates electron hole pairs. Electron concentrate one on side of cell and holes on the other side. Connecting the two sides creates electricity. Quantum dot displays. Quantum dots are value for displays because they emit light in very specific distributions. This can result in a display with visibly more accurate colors. Tuning the size of quantum dots is attractive for many potential applications. The conventional color of liquid crystal display is usually backlit by fluorescent lamps. In light emitting diodes, several methods are proposed by using quantum dots to improve existing light emitting diode design include quantum dot light emitting diode and displays and quantum dot white light emitting diode displays. In medical imaging, the photo below shows human red blood cells in which specific membrane proteins are targeted and labeled with quantum dots. The number of purple features which indicate the nuclei of malaria parasites increases as malaria development progresses. Cell imaging. Quantum dots last longer in your system and are brighter than many organic dyes, and the fluorescent proteins previously leads to illuminate the interiors of the cell. They also have the advantages of monitoring changes in cellular processes, while most high resolution techniques like only provide images of cellular processes. Frozen at one moment, quantum dots can be designed to bind to specific cell receptors. In this way, researchers can monitor all kind of process in living cells. Locating cancer cells. This picture shows silicon quantum dots fluorescing inside the cancer cells. Cancer cell imaging. These quantum dots can be put into single cells or lots of cells in the tissues of living organisms. In future, it is planned to attach specific antibodies to the quantum dots. When injectable into a body, the quantum dots will find and bind to the cancer cells and illuminate them when they fluoresce. This on the screen, this diagram is used in cancer cells in a live mouse. The new generation of quantum dots have far-reaching potential for study of intracellular processes at the single molecule level. High-resolution cellular imaging.
ती खाली अपलोड करू ते नाही तर टिक केलेलं आहे
कोणी अपलोड केलेलं आहे?
स्वतःचे अपलोड केलेलं
आम्ही तिथंच केलेलं आहे की इट्स मेड फॉर किड्स, पण मग चालणार आहे का बुवा असं? नाही तर मग ती काय ते HOD सरांचं इथे उगाच प्रॉब्लेम नको आपल्याला. मी विचारून घेते सरांना. Cancer cell image. These quantum dots can be put into single cells or lots of cells in the tissue of living organisms. In future, it is planned to attach specific antibodies to the quantum dots when injected into a body. The quantum dots will find and bind to cancer cells and illuminate them when they fluoresce. Second, targeted drug delivery. In this, we attach drug molecules to the quantum dots, which will then be able to deliver the drug just to the cancer cells where it is needed. Current anti-cancer drugs tend to have a range of unpleasant side effects because they affect the whole body, not just the cancer. Solar cells. Photovoltaic effect. p-n junction. Sunlight excites electrons and creates electron hole pairs. Electrons concentrate on one side of the cell and holes on the other side. Connecting the two sides create electricity. Medical imaging, in which a specific membrane proteins are targeted and labeled with the quantum dots. The number of purple feature which indicate the nuclei of malaria parasite increases as malaria development progresses. Cell imaging. Quantum dots last longer in your system and are brighter than many organic dyes, and fluorescent proteins previously used to illuminate the interiors of cells. They also have the advantages of monitoring changes in cellular processes. While most high resolution techniques like only provide images of cellular processes frozen at one moment quantum dots. In this way, researchers can monitor all kind of processes in living cells. Thank you.